Claudio was saying, actually, yeah, I'm going to go back to my very, very first job. I was straight out of university. So it was that phase in my life where I knew absolutely everything until I learned something new. But then I really knew it all. And then soon after, you learned something more again. And then, yeah, I think it's almost 20 years later that you kind of admit and realize you never stopped learning. But back then, the only place where, if you wanted to work with Erlang, the only place where you could do it was at Ericsson. So the year was 1995. And so I ended up at Ericsson training and consulting arm, and we were given very, very strict guidelines to follow when we were implementing our code. And we didn't think that much about it. For us, the whole software development cycle ended when we went in and checked into code into ClearCase. And yes, I used ClearCase when it was still considered cutting edge. Now, every now and then your test might come back with some error reports, but that was it. The project cycle was so long, we never saw our code go into production. In 1997, I was working on Ericsson's broadband solutions, including ADSL, and that started going into production in 2001. Colleagues were working on GPRS, which became 3G, 4G LTE, 5G. Once again, similar timelines. And one of the things we were told at Ericsson, we were very critical about it, but we were given very, very strict guidelines to follow. And we didn't quite understand what these guidelines were. We just did as we were told. And it wasn't until about a decade later when I was on call 24/7 for a messaging solution and had to go in and start troubleshooting production issues that I got my aha moment and really went in and understood the guidelines which were being given. And that's what I was going to talk about today. Now, how many of you have Erlang or Elixir in production? And so keep your hands up. Now, if you have never been woken up in the middle of the night as a result of a call-out, take your hand down. So a few people admit to having been woken up in the middle of the night as a result of a call-out and your code going down. And note here, mine came down as well. And the reason is, was my background. When I developed and started handling and supporting this production, this system, this messaging system, I had the lessons I'd learned from Ericsson. And well, it wasn't Ericsson, it was the telco space. And what is so special about telecoms? You pick up the phone, you expect to hear the toot-toot on the other end. If you don't hear that toot-toot on the other end, it's pretty simple. Back then, you knew that it would make the front pages of the newspapers. The legislation stated that no matter what natural catastrophe or disaster was happening, you still had to be able to dial the emergency services. And not only, there were massive penalties when the network went down, and it was the fault of the infrastructure provider. So that meant you shipped code which never failed. And what applied back then still applies today in some shape or form. Plain old dial phones might have been switched with your online gaming, financial systems, e-commerce sites, video streaming, messaging solutions. And well, you might not make the front pages of the newspapers, but your users will flock to social media and moan about yet another outage. And I think the real critical part when you're developing these systems, which never fail, is to avoid single points of failure. Do we have any New Yorkers in the room? There are a few, yeah. Do you recognize this building?
I do.
Yeah. Sorry? No. Yes, so this is the ATT Long Lines building in Tribeca. It's an example of a brutalist architecture, and I got that from Wikipedia. It has no windows, and it was built to withstand a nuclear fallout. It opened in 1974, and you can guess what they used to put in there. Phone switches. And it literally is one of the most secure buildings in America. And the basement has a tank. So when I went in, I was lecturing at AT&T, and they actually told me the basement of this building has a tank with enough gas to power backup generators for 2 weeks. So there is a blackout in New York. For 2 weeks following the blackout, you'll still be able to make your phone calls. And in fact, after 9/11, it was the only fully functional building south of Canal Street, which was working. Phone switches today have become much, much smaller. So those of you who might not know it as the AT&T building probably know it as the building where they suspect the NSA has a lot of computers. That's why it's making the headlines these days. But it still has a lot of phone switches. And, no, they're not mechanical anymore, so they're much, much smaller. So the key here is that you basically, when you're developing a system with requirements of high availability, you need at least 2 of everything. And so, yeah, you need redundant power supplies. You need battery packs. You need redundant hardware. So if you ask Joe Armstrong, he'll say you need at least 2 computers because one might get struck by lightning. If you ask Leslie Lamport, I think he takes a slightly more scientific approach, but he'll say you need at least 3 computers. But they're both right in their own way. But you need redundant data centers. You need multiple you need multiple cloud providers. I'm sure you've heard about the story of everyone who got locked out of their house when there was an outage on Amazon, on EC2. There was another outage just a few weeks ago as well. And even there, sometimes a single point of failure is not enough. There was one switch which was handling all of the international trunk for a city of many million inhabitants. And it was an AXD 301 switch. It had been running for 3 years. It had never been upgraded, never required any support, any maintenance. It was never rebooted. And it just ran, it just worked. And after 3 years, Ericsson approached the telco provider and said, we're not supporting that version of the software anymore. And we need to upgrade the system. And the telco provider agreed, reluctantly agreed. And as it was free releases, they usually did software upgrades in real time. But as there were 3 hops they had to do, they decided to keep it simple. And in doing so, they agreed to reboot the machine. They went in, they did the upgrade, they rebooted the primary node. So all of the traffic then fell over to the standby node. So once again, ensuring no single points of failure. And they tried to reboot the primary node, and it wouldn't start up. That board would not start up. Panic. They tried to upgrade the standby node, which had become the primary node. They rebooted it. Nothing happened. It wouldn't. Once again, it wouldn't start up even there. And it took them a week to actually get that switch up and running again. One of my colleagues, forget FedExing new hardware or new boards, they would get stuck in customs in that particular country. I had a colleague actually fly over, hiding the boards in his raincoat, smuggling them through customs to get this switch up and running again. And obviously it didn't look good. They went in and did a postmortem over what had gone wrong, and identified that in the boot sectors of the hard drive, the boot sector, in these hermetically sealed hard drives, the boot sector which was rebooted was in the external parts of the drive. And so for 3 years, the head of the disk had moved backwards and forwards, never touching the external parts. This very thin layer of dust had accumulated exactly on the boot sector. And when they went in and tried to reboot the system, it just ground to a halt. It just got stuck. And they were able to run it. So today, the AXD 301s regularly do kind of hard disk gymnastics every day at midnight when the traffic is lower, literally, to spread the dust everywhere. But this comes as a reminder of 2 things. One is that it might not always be the software which is at fault. There are many other components you need to consider. But B, if you do get an issue or an outage, make sure that you address it for future releases. Now, I'm not a hardware person. I'm going to focus on software here. And this is, and basically, with an argument that by investing in proper monitoring in the early phases of your software development, you end up saving a lot when it comes to maintenance. Now, this is just I picked the first software lifecycle cost pie chart I could find online, because they pretty much all tell you the same thing, which is that the cost of maintenance of your system varies between 60 to 80%. Now, by investing proper monitoring in your requirement, specification, design, and coding phases, and obviously, well, testing and integration as well, my argument is that you can actually go in and massively shrink the overall cost. So it's a cost you have to pay up front, but which will then give you multiple savings during the life cycle of the system itself.
What is the assumed lifetime here?
This could be years, decades. I'm not sure about the specific chart, but usually, I would guess 5 to 10 years is usually your typical average, your lifetime of the system before it gets replaced. But obviously, it will vary from system to system. Now, proper monitoring, what it does, it gives you visibility into what's going on in your system. And more importantly, it gives you the opportunity to react and act on the information you collect. So you use this data for two reasons. One is preemptive support, so actioning items before they escalate. And the second is postmortem analysis. So once something has gone wrong, you need to quickly figure out what it is which has gone wrong, fix it, so not waste that much time trying to figure out what went wrong, fix it, and make sure it never happens again. So make sure you start getting early warnings that it starts sitting. And it's a secret source of high availability when you're writing systems on the beam. And there are three distinct things you monitor or you collect in any system. One of them, the first one is metrics. And you obtain, they're usually numerical. You obtain them by polling a value at a particular point in time. So as an example, it could be the memory the beam is using. Now, believe it or not, I think you go back 10, 15 years, about 80% of all of the Erlang installations out there, those maintaining those systems had no idea how much memory they were actually using. And it just doesn't, you don't need to stop at memory. It could be how many elements do you have in a table, in an ETS table, which could then directly map to the number of concurrent sessions or active users. You then have logs, which is an entry into a file or a database. And what it does, it records an event or a state change in your system or in your environment. Could be that a particular call is started, so you connect the users. It could be that you've got a network partition, so that the network between your two machines goes down, or that you've recovered. It could be a financial transaction which you're logging. So, we failed with a credit card transaction, or we were successful. And you then have a subset of logs, which we call alarms. And everyone in the telco space will recognize alarms, less so outside of the telco space. And it's one of the things where I've, in my career, always been pushing out into other verticals. So started in telecoms, I got into banking. Why aren't you using alarms? Oh, what are they? The same with instant messaging or with any other system. And alarm is basically a set of logs which can be raised when an event happens, so you get a network partition as an example, and can be cleared when that issue is undone or resolved. And resolution can either be manual, so it's your system administrator which tripped over the network cable. You raise an alarm that you've got a network outage. He goes in, he plugs it back in, we realize that the network's up again, you clear it. Or it could be automatic. So all of a sudden a node goes down, you raise an alarm that the node is down, that user can't access the database, you reroute them to an active database, to a fault-tolerant one, a redundant one. And in total, there are two types of metrics. You've got system metrics, which are metrics which could come from the system itself. So it could be memory utilization, disk, CPU, calls. And you've got business metrics. Business metrics relate to the business logic of your system. So it could be the number of attempted logins, the number of failed logins, successful logins, the reasons for logins failing, so unknown user, bad password, and so on. Now, let's go in and look at memory itself. So memory usage is one of the key metrics you always have to monitor. And you can probe the total memory usage of the beam, but if you run out of memory, you've got a spike in memory usage and your beam runs out of memory. Knowing that you run out of memory doesn't really help you. What memory type caused you to cause the spike? What caused it to crash? And in this particular example, I don't know how much you can see it in the back, but the 5th of November, all of a sudden, there were 2 small spikes. So these are, this is just plotting memory. It's got the amount of memory used by atoms, because you can dynamically create atoms. It might be a memory leak in your system. It's the amount of memory used by Erlang term storage, ETS tables, because once again, you might keep on inserting elements, forget to delete them, you might have a leakage, or it could be very valid that that these your user base is increasing. The total memory usage, which is the top line here, which is the sum of all of these, memory used by the binary heap, the memory used by processes, so the aggregate sum of all of the process heaps, memory used by your code, and system memory. And we're seeing down here 2 small spikes, which together cause a slightly larger spike, which is code memory and system memory increasing. So more or less, probably on the 5th of November, there was probably a software upgrade which was done, and a few more modules were actually loaded in the system, which caused this little spike. And when they realized that these modules actually worked and they made the release permanent, they maybe purged the old versions of the module, causing a reduction once again in the total memory consumption. And so this is just interesting to see, but what's should be worrying here is that over the period of about a week, memory utilization increases by 50%. So it goes from slightly over 2 gig to over 3 gigs. And, and this should act as a warning that if this trend continues, your system might eventually run out of memory, maybe next month. So at least you've got enough time to go in and action it. And you notice right here, what's following it here is the process memory. And that gives you time to go in and figure out, are we maybe, should we maybe force through a garbage collection? Or maybe these inactive processes which have not done a full sweep in the garbage collector? Could it be that our user base is actually increasing? So this is the aggregate sum this is the aggregate sum of all of the processes. Maybe we're having, we have a process per user. If that's the case, we didn't need to throw more hardware, more memory at the problem. Here's another example over a restart. Once again, a node's run out of memory, and it's restarted. And the restart occurred at probably 4 a.m. And for a few hours, it was, it took a while to recover, after which it went back to normal operations. Do you see that? Now, usually, and what we were monitoring right here was the whole message queue length. We took the sum of all of the message queue lengths of all of the processes and plotted it over time. When you get when your node runs out of memory, you might get a crash dump, which could be gigabytes large, because it might contain a lot of data. Good luck navigating through it. Or it might be 0 bytes long. If you're out of disk space, or maybe Heart, you're writing it, it's so large, Heart figures out that you're hanging because you don't acknowledge the heartbeats, and it goes in, takes down the VM, and so you might end up without anything, and you don't really know. And indeed, you could use the observer to find out which processes have large message queues, but without the historic data, when you come in the morning, depending what time you come in, you won't see this data. You won't see this historical data. It's almost like you're stuck in front of a screen hoping for the crash to happen. And I've seen people doing it, hoping, let's hope the crash will happen now. I hope to catch it. I'm working, but keeping my eye on it, instead of actually getting those metrics and using them later to figure out what went wrong. And here it's obvious. Something went wrong with a huge spike in messages. The total message queue was 150,000 messages. There must have been fairly large messages. And that caused the node to run out of memory, restarted, cleared the process queue. And whilst restarting, there was a lot of activity, which then evened out. Now, there are 4 very common types of metrics, metrics. One are counters, which you just go in and increment. You increment them one by one. Gauges, which is a value at a particular point in time. So this is a typical example of a gauge where we go in and pull the total size of the message, or the total message queue. You've got histograms, which are readings over time. So they could include latency, which you get the average latency, the number of requests per second, minute, hour, day, and so on. And then finally, you have spirals, which is a value over a sliding window count. So those are your typical metrics you tend to collect. Here's another example which we detected, and it was an incredibly slow recovery after a system had been restarted. So system worked really well. It was restarted at around 12 o'clock, and for about 4 hours, the message queue just spiked to about 4,000 messages. And this is an example of Mongoose AM, which was running on a 4-node cluster, where after a crash, one of the 4 nodes was really slow at restarting. Now, had a slow recovery. And it took 4 hours to completely recover. And what happened is each node was handling about 500,000 connected users. The node crashed, so you lost a TCP/IP connection. That meant you need to log on again. You need to recreate a new TCP/IP connection. So you need to, authenticate the users, notify all of the users. First that you got offline, then you're back online. So it becomes a fairly expensive procedure. And in the same graph right here, what we do is we've got a cumulative counter here, which shows the number of successful Mnesia transactions. Every login is a transaction commit, a successful transaction. And we see here that right after the outage, we slowly get up to about 500,000 users, which get reconnected. We look at the number of ongoing transactions, and in the grand scheme of things, it seems fairly stable. So, and this is also what caused the long message queue I was talking about earlier. And I'll get back to that in a second. Any questions so far? No? So, so from metrics, we actually have, the next thing you need to be very wary of is logs. And try to log as much as possible. This is an example of logs you get completely out of the box when you're using Erlang and Elixir. They're what we call the SASL logs, the System Architecture Support Library logs. And automatically, if you're using OTP and an error happens within a behavior, the behavior itself will automatically log an error report. And these error reports, you can either push them to file, you can display them on the screen, or you can write your own handlers, which do whatever you want with them. Now, if an error report results in a crash report, you then get a crash report, once again, from the behavior itself, followed by a supervisor report. The supervisor report is created by the supervisor when it gets told that a process is terminated, that behavior is terminated, and there's a new supervisor report telling us that, hey, I've restarted that behavior. And you get these in OTP. Now, we'll have customers with 200-300 nodes in production who have no idea that their processes are crashing. Because the process crashes, it gets restarted. Maybe a user gets a timeout or presses retry, and then they actually get what they're looking for. So they don't realize it. And I think one of the things is you need to monitor. You need to monitor the logs. It's no good just getting them. You basically need to push them in a particular location, maybe result in them sending an email, sending a Slack notification, or making sure that you go in and look at them themselves. Now, there are cases where you go in and use the logs later when you're doing postmortem debugging as well. So it's always a balance of what you do. Now, these are, in my view, that's how logging should look like. These are very wise words from Pat Helland. The truth is the log. The database is just a cache of the subset of the log. when I was supporting this messaging system, I received an email from support saying, oh, this user, and I got the phone number, on Saturday was really, really angry. He never got his text messages telling him that his favorite team had scored. And he only got them after the match. Now, this was a system which had handled millions. It handled all of the shortcodes for a cell phone provider in the UK, all of the shortcodes. And so it was a lot of data going through. You can imagine, millions of messages every day. All of your Big Brother voting. So this was back in Britain, so it was equivalent of Britain's Got Talent. X Factor, all of these trashy TV programs where you still used to vote by SMS. So this was about 10 years ago. And right, it's almost like looking for a needle in a haystack. How do I prove my innocence and get someone else to admit guilt? Easy. I picked up, using this principle, I took the phone number and looked at all of the inbound SMSs. With that phone number, I found that 3 messages had been sent on the Saturday. This was still on the live machines. We moved the logs off every hour, but kept 2 weeks of live logs for these types of errors. So I found 3 SMSs which were sent with the log with this number, and it was the first goal which was scored, sent at the right time, probably. The second goal, which was sent probably 20 minutes later, and then a third SMS, which was probably the final score of the game. The messages themselves were stored there, but they were encrypted, so I didn't bother looking at them. Now, with each message, there was a unique identifier associated to it, so which we created when it entered our system. I took that unique identifier, and I went in and looked at where we did the logic checks for the system, because this could have been a prepay user, and that means that 80% of premium rate SMSs fail on prepaid subscribers because they've got no credit. But no, it was a postpay user. And we'd also logged that he was allowed to receive premium rate SMSs, and his account wasn't suspended. So all of the checks were done, were correct. So next thing we did, when all the checks succeeded, is we sent the message off to the SMSC, the Short Message Service Gateway, which then sent it off to the phone. And immediately, the Short Message Service Center gave us back another unique identifier, which we logged, and which was then used whenever we received delivery reports. So I went into the delivery report log with this unique identifier and found that immediately after sending the SMS, we got back a handset detached message for the first SMS, second SMS, third SMS. And then at half-hour intervals, the retry was every half an hour, we kept on getting back handset detached, handset detached, handset detached, 3 times for every SMS for each of these individual, until probably half an hour after the matches had ended, delivered. So this took me about 1 minute, 1.5 minutes. I replied to the email telling them, well, it's not us. The user was out of coverage or had his phone switched off. So I recommend that he moves to a better network with better coverage. And also suggest he gets a life, because what is he doing complaining, not receiving the text messages? Doesn't he have better things to do on a Saturday than to follow football? I'm not a football fan. And to which I got an immediate reply back from a friend who said, this is the CEO of the company, but I will express myself in slightly more diplomatic terms, but thank you for your help. And later realized also that not only was he CEO of the company, he was also chairman of the soccer club. So, and then he was probably in the stadium with 30, 40,000 other people, and that the network couldn't handle that many connections, that many phones, and so he never got the SMS when he was there. So the phone was probably on, but he basically had a no network on it. So it's this is and these logs, they were not only used for debugging. They were not only used to prove our innocence and push the guilt somewhere else. They were used for billing. We knew exactly, how many users had received premium rate SMSs, how many had failed. We knew what they cost. It was used for audits. They'd check our logs, and they'd check the logs on an SMSC. And they were used by marketing to analyze trends, to analyze user behavior. So, a wide area of items. But once again, I keep on saying, support and maintenance is 60 to 80% of your cost. Reduce it by not having to waste years, looking for needles in haystacks. Find, what caused the problem in half a minute, in a minute. And in our particular case, had it been a bug on our end, the log trail would have stopped somewhere. It would have actually stopped somewhere, and we would have, realized, okay, between this phase and this phase, that's where, the SMS failed, and then we'd maybe go in and look, was there a crash report? Oh, here's the process which crashed. And we'd know exactly what state the system had been left in. And finally, alarms. That's the third part. And alarms are raised when certain criteria are met. It could be that you're running out of disk space, that your system can handle maybe anyone from WhatsApp here, 1 million users on a single machine, or 2 million, sorry. So 1 million was 2011. So 2 million users on a single machine. And if you go above that threshold, you might want to start throttling. Might want to start rejecting requests. But also you're alerting whoever's doing the operation that you're hitting certain limits. And these alarms are raised when these criteria are met. At the same time, though, they're cleared when the criteria are no longer valid. So you go in and you delete some files, or the number of connected users goes down. And there are 2 types of alarms which are generated. And the only alarms I've actually been seen used outside of telco space are threshold-based alarms. So you pull in some metrics, and then in Nagios, go in and say, oops, we've hit 80% of memory utilization. You raise an alarm right there. Those are the only ones I've seen used out there. In the telco space, you open a cabinet door. This millisecond you open the cabinet door, you'll raise an alarm alerting the operator that the cabinet door is open. If fan breaks, you immediately raise an alarm. The second your sensor detects that your temperature has gone over a certain level, you'll raise an alarm. Your network connectivity to the database goes down. You raise an alarm when that socket goes down. That millisecond the socket goes down. You do that immediately. You don't do that when once a minute you go in and you send your poll request and realize you can't reach the database. You do it immediately, because this allows you to actually go in and react the very millisecond you realize something is wrong. Because that's the only way you can ensure that by reacting and trying to avoid issues is the only way to stop you from having an outage. And as an example, also alarms have different severities associated with them. So a 70% this full alarm might have a severity minor. So if it's during office hours, you send out a PagerDuty request, and someone might go in and look at it, just make sure that the increase in disk usage isn't too big. If it's an 85 disk full alarm, it becomes a major alarm, and you might want to trigger a call out only between 7 a.m. and 10 p.m. But you hit a 95% disk full alarm, you want to trigger a call out 24/7 and have someone look at it immediately just to make sure that everything's okay, do some housekeeping and bring those levels down again to something respectable. So going back to the previous example, where I was showing you the message queues and all the media transactions, the first alarm we got when we were recreating the error to figure out what was wrong was a process message queue major alarm. So monitoring all the queues, as soon as we hit the process limit of 100,000 messages in a single process, we basically raised an alarm. What was caused? What caused these 100,000 messages? Well, trying to figure it out, we realized we had another system limit alarm. We tend to monitor all of the system limits. So the maximum allowed number of processes. You know that you start your VM, you have something like 30,000 processes which you can have. And you can override that and increase it. But the default is 30,000. Works for most users. Maximum number of ETS tables. The maximum, and so on. So we immediately got that the table count, ETS table count, which by default is set to 2053, was reached. And well, exceeding 90% of the limit, 2053 was basically 100%. And what caused this? Oops, underneath we saw invalid app file, application file, but also another alarm, which was application MongoDB versions are different on the family. So what had happened was, when doing the deployment, one of the 4 nodes, the node which had all of the backup, had the wrong version of the database drivers installed. And it was a buggy version. 3 of them had been upgraded, but not the 4th one. And in the shell commands, we actually, which we also log, every time a shell command is executed, it gets logged. We saw, where this error was made. It was a manual error. It was before they had automated all of the push-outs. So they fixed, they upgraded the MongoDB driver and got it running again, and immediately, the throughput on the MongoDB driver, which was causing that bottleneck on that particular node, went up to the same level as all the other drivers. And problem solved. With this level of visibility, it took a couple of hours to address. Had we not had this visibility, I would have guessed probably 2-3 days at least, because of repeating, recreating the error, monitoring, and looking. And how much time do I have? 5 minutes, yeah. So, I think an example which I talked about in my book, I believe, is, when it comes to taking action, is, there was someone who had uploaded an unauthorized patch on a node. They tried to fix a problem, upload an unauthorized patch, first-line support, realized it didn't solve the problem, they deleted the beam file. And after having deleted the beam file, they thought that's it, not realizing they had to actually purge the module from the beam itself. They escalated it to 2nd line, which quickly pushed it over to 3rd line. That's usually is the way it happens in the Erlang world. And it took the engineer troubleshooting this issue on this live switch 40 hours, only to figure out that these 2 nodes were running different versions of a module. So once again, that happened once, never happens again, because we'll go in and monitor. You should monitor the versions of all the modules. Actually, we take an MD5 encoding and you generate a unique key for every single beam file and then compare them. And as soon as there's a difference, we raise an alarm. So, a lot of use, there's a lot of use for these metrics. Marketing and analysts use the business metrics, to study long-term trends. You've got developers which use the collected information to improve the performance and reliability of your systems, and possibly troubleshooting issues after they've occurred. You've got operations who use them to predict trends and usage spikes, ensuring that there's enough capacity, both to scale up but also scale down. Just as important, we've got users who've got no idea what the throughput is in their system, where they could very well get away with 2 instances instead of 4, and then just fan out during peaks. Now, obviously, DevOps collect the data to monitor system, detect abnormal behavior, and prevent failure. And what is it you do? What do you do? It's when they prevent failure, you use it. It's preemptive support. It's being able to react in an automated way before before even a human gets woken up out of bed. And if you think of it, 5 nines is about 5.5 minutes. It's 4 o'clock in the morning. You get a call out from first line support. Just getting out of bed, turning on your laptop, getting that coffee is you'll probably have hit and used up about half of your downtime allowance for that year. So most of the time, whenever you detect an alarm, trigger off a script, which automated support, which will do things for you. You hit a 70% is full alarm, tar your logs. 85% is full alarm, go in and delete old logs and run a script which does a bit of household, a bit of cleaning. 95% is full, shut down all of the non-critical logs and delete whatever you don't need or FTP them over to a separate machine. as an example. And this is just one of the many examples I could give you, because that also another thing you need to do is throttling. So a reliable system is one that is predictable. And going in and saying, oh, we're awfully sorry, there are too many users on the system, come back later, that is a reliable system. It's predictable. Versus you not being able to upload a page and getting a timeout. And so what you do is you use the monitoring for load regulation and to basically push things out. And finally, postmortem debugging is what the examples I gave you earlier. When something's gone wrong, your node's restarted, you've lost everything. You lost the state of that particular node. Use your logs to understand what state your database was in. Use your metrics to understand the state of the system on its own. Yeah. And remember, pretend this person right here is your colleague who gets woken up in the middle of the night to address an issue you might have caused. And also pretend he knows where you live. So, don't give him an excuse to visit. Provide them with the necessary visibility, which allows them to isolate and address the issue. And this visibility, I think it's critical. You need to plan it as part of your requirements, design and development phases. It is not something you can go in and bolt on as an afterthought in your system. You need to do this very, very early on. Yeah. So, any questions? Yes.
Do you have any experience with velocity-based metrics? And
so anything.
The example I've used in the past is, thresholds are great, but a lot of times it's much more important how fast you went from 70 to 80 than the fact that you hit 80.
Yes. So I think my experience there would be around incremental counters, where you pull the counters every second, and you're able then, or every regular time interval, and you're able then to predict the spikes when you see the increase, from one item to another. We've never acted on them, but I think it's a very, I'm sure there are systems where applying that would be critical. And the challenge is every single system is different. There is no one size fits all. So, yeah. Yes?
In this age of open source, and you're having logs distributed across multiple systems, how would you go about collecting those logs and viewing them in your debugging example that you have? There are tools out there which will do it for you. So Logstash is the first one which comes to mind. Splunk is another, which and these are SaaS tools. You also have tools you can run on-prem, and once again it's very important that you integrate with the tools your operations teams is comfortable with. You cannot inflict new tools on operations because you're trying to introduce Erlang or Elixir. It will not work. The number of times, if I only received a cent for every time I got told, oh, operations won't take it over because it doesn't run on the JVM, I would have been retired by now. You need to integrate with the tools operations is comfortable with, because you're coming with a new ecosystem, basically. And familiarity is critical. We heard it this morning in the keynote. It's just as valid with operations teams. And so you give them the visibility, even better visibility than what they're used to in their tool chain, and everything will be forgiven, even the skunk works you did when bringing Elixir in production. Okay, any more questions? So there are two things. There's a blog post you might want to read on Erlang and Elixir DevOps from the trenches, where we describe a few war stories, some of which I spoke about here. And there is also chapter 15 of Designing for Scalability. I really go into detail over what I talked about on monitoring and preemptive support. So with many of the examples. And the book you can find on BitTorrent if you like to try before you buy. And if you like it and you're happy with it,
just use discount code ALFD, which will give you 50% of the digital copy and give you 50% of any other O'Reilly title as well. So shouldn't be telling you that, but yeah. We'll cut it off in the video later. Yeah.
All right. Thank you, Francesco. Round of applause.
Thank you.